Alright, so we're going to talk about standard S1. To add and subtract, multiply and divide complex numbers. So today we're going to need to touch on a branch of numbers that you've not ever been exposed to yet. They aren't scary. They actually have existed all along. We just haven't had a need to learn them until now. This branch of numbers is called complex numbers. Not because we're pulling something out of thin air, but because they're numbers we cannot plot on a normal number line. These numbers, not only are they called complex numbers, but you'll also hear them referred to as imaginary numbers. These numbers allow us to continue working with a problem or solution when before we would have had to write no solution. An example of when these numbers would come into play would be in a situation like this. Okay, so if I gave you this problem, you would say, all right, well, to get rid of the square, I'm going to take the square root of both sides. You can get x equals the square root of -4. It's been pretty much drilled into your head all along that a square root or a negative cannot be underneath a square root, so we would have said no solution, which technically is correct, because there's not a number that you'd be able to plug in for x to get you square root of a negative number, because square root is the opposite function of squaring, and anything that you square is going to be positive. So -2 times -2 is going to be a +4. 2 times 2 is a +4. You always get a positive number when you square, and so you can't ever have a negative value underneath the square root. It just doesn't make sense. So we would get stuck. So if you got the square root of a negative number, you would just have to stop the problem. There are situations, and we're not going to dig into a whole lot of them right now. We'll do that with the type 4 problems. But an electrician or anybody who works with circuitry in a computer or anything like that deals with values that look like this. And so they have to be able to do something with them. They can't just stop and say no solution. They have to continue on with the problem or with the circuit. And so they have to be able to write them in a way where they can actually go forward. So with the introduction of imaginary numbers, the solution here would actually be plus or minus 2i. Because technically what's happening here, which we'll get to under the properties, but you're pulling out the negative and making it an I. And this shows us that, okay, we can't plot this on a number line. There's not an I on a number line. But it allows us to add and subtract, multiply and divide values that we weren't able to before when we had to write no solution. So it's a different notation to write this concept so that we can continue going forward with the problem. Alright, normally we'd have to write this question with no solution. Okay, I already talked about that. But with complex numbers and its counterpart, imaginary numbers, we can now write an answer and be able to use it further. Here's an example or an explanation of the complex number structure. So you start with this overarching umbrella of complex numbers. And then it branches off. And over here you have imaginaries. And over here you have real numbers. Imaginaries and reals are both written the same, except with real numbers you have a, which is like a real number you can plot, plus an imaginary. That makes up an imaginary number. A real number is a part you can plot on a number line, plus an imaginary part, but b is always equal to 0. So you never see that imaginary part written. You just only ever see the real part that you can plot. Okay, now I know that can feel like overload. So just relax. Soak it in. We're going to talk through some concepts here again and then some properties. But the actual thing you have to be able to do at this point with complex numbers are add, subtract, multiply, and divide. And you actually know how to do all of those things already. So don't flip out. Just relax. We'll go forward. It'll be fine. Okay, so a complex number is a number that has both a real part and an imaginary part. imaginary number is a concept or a notation to deal with values that you cannot plot on a number line. Because as we already stated, imaginary numbers come into play in this type of situation, and there's no real true answer to the square root of -4 because it's not a number that you can plot on a number line. But in order to use that kind of solution for something, we have to be able to write it in a different notation. So that's what an imaginary number does for us. Conjugate. Conjugate is, we'll call it a manipulation technique. Solve or simplify problems. If you have A plus BI, then the conjugate, which sounds like a really complicated term, but it's just the name that's given to the same expression except the sign in the middle is changed. So only sign in the middle changes. The reason for this, as you'll see when we multiply and divide, is by multiplying or dividing by the conjugate, it allows us to get rid of some variables and help ourselves out. Okay, let's flip. Properties of imaginary numbers. Two main properties. Definition: the square root of -1 is I. So when you see an I, what that's representing is this concept of the square root of -1. Second property is that I squared. So if we were going to take this and square it, what you're doing is you're really squaring the square root. And so you end up getting that I squared is equal to -1. That's why being able to move forward with a problem like this by changing it to an imaginary number is useful, because a lot of times you end up getting an I squared and then you can change it back to a real number, which is nice. I think we might talk about that tomorrow, but I'll leave it right now. Alright, so you have an overview of complex numbers, their role in math, and some of the properties. So we're going to get practicing the standard, which is to multiply, add, divide, and subtract. Alright, so to add and subtract complex numbers, you add, subtract your like terms. When you multiply complex numbers, you're going to FOIL. When you divide by complex numbers, you're going to multiply top and bottom by the conjugate. You actually have done each one of these things before. You just didn't know it. Alright, let's look at example 1, adding and subtracting complex numbers. I think we only need maybe 2 examples here, so we're going to make an A and a B. Let's say you have a complex number, 2 plus 3i, and we're going to add 4 minus 5i. Okay, so when you're adding and subtracting, these are both complex numbers because they're real parts plus imaginary parts. Real part plus imaginary part. But to add them together, to get another complex number, you add and subtract like terms. So the like term with 2 is 4, so 2 plus 4 is 6. And the like term with 3i is -5i. 3i minus 5i gives me -2i. That's it. That's all you have to do. If we were to look at 4 minus 5i and subtract 7 plus 2i, let's say. Again, you're going to subtract like terms. So you have to be careful here. If you want to, you can distribute this negative through before you add like terms. But remember, or keep in mind that you're subtracting this number and you're subtracting that number. So 4 minus 7, those are my like terms, gives me negative 3. And then negative 5i minus 2i gives me negative 7i. And you're done. Okay, so pretty straightforward, nothing fancy. Just add and subtract like terms. Go ahead and flip. For example 2, multiplying complex numbers. Okay, let's look at multiplying these two complex numbers together. You'll notice that these actually are binomials. And I know we haven't really talked about foiling yet, but it should be a concept that you're all pretty familiar with or have seen multiple times, multiple classes before. So we're going to FOIL these together. Now, keep in mind, FOIL means first, outer, inner, last. So we start with multiplying my first terms together. Because technically what you're doing with FOIL is you're distributing the 2 and the 3i to every term in the next parenthesis. FOILing is just a method that we use to make sure that you don't miss any terms. So 2 times 7 is 14. Outer is 2 and 5i, that gets me 10i. Inner is 3i times 7, that gets me 21i. 3i times 5i gives me 15i squared. Now, whenever you see that I squared, that should ding a bell. Ding, ding. And we should remember that I squared is equal to negative 1. Because back here, because we made this definition that whenever you see an I, what that really means is that it's the square root of negative 1. If we were to square that, it would cancel out the square root, just leaving you with negative 1. That's really important when we come to a problem like that, like this, because we're going to add my like terms, 10i and 21i, to get 31i. But then this changes to negative 1, so then you have plus 15 times negative 1. So it changes that back to a real number. And then you can add your like terms here and here. So 14 plus a negative 15 will give you negative 1. And you can stop there. Okay, now I know I'm going through this quickly, but hopefully you're following along okay, and we're going to be doing whole group review tomorrow as well on this. But some of you are going to pick this up real fast and be able to do these problems real quick. Again, it's not anything too complicated in terms of the algebra you have to do because you know how to FOIL, you know how to add and subtract like terms. It's going to be more the concept of complex numbers we're going to have to talk about. And keeping in mind that this I squared, whenever you see that, that's pretty important. You have to change that to a negative 1. Okay, we're going to do 1 dividing complex numbers together. 3 minus 2i divided by 5 plus 3i. Okay. When you're dividing complex numbers, you can't just cancel out the i's. Okay, this is glued together on the top. The only things you can cancel is if there was a 3 minus 2i down on the bottom too. Then you could cancel them because you have like terms. But here, this part that's glued on the top is way different than this part that's glued on the bottom, so you can't cancel stuff out. When you're dividing complex numbers, we utilize the conjugate that we've talked about. The conjugate is the same thing as the denominator, except the sign in the middle changes. So we're going to multiply by this fancy form of 1, the conjugate. Okay. And then you'll see we have 2 fractions. Now when you have 2 fractions, we multiply or we simplify by multiplying across the top and the bottom. And then it becomes looking like a lot of problems like we just did, for example, 2. So we're going to deal with the top and then we'll deal with the bottom. So when I deal with the top, I'm going to go ahead and FOIL those together. First terms, 3 times 5 give me 15. Outer terms, 3 times negative 3i gives me negative 9i. Negative 2i times 5 gives me negative 10i. Negative 2i times negative 3i gives me positive 6i squared. Again, ding, ding, ding. We're going to have to do something with that. Now let's do the bottom. 5 times 5 gives me 25. Outer gives me negative 15i. Inner gives me positive 15i because negative 15i, and then here 5 and 3i give me 15. Okay, and then 3i times negative 3i, my last terms give me negative 9i squared again. Ding, ding, there's another I squared. Now we're going to simplify. So on the top I've got some values I can take care of. If you want, you can say, all right, I recognize that that I squared is there. That's going to change to a negative 1, which is going to make that a negative 6. So when I add, I'm going to take 15 and add negative 6 to get 9. And then here's like terms here, negative 19i. Now on the bottom, and this is why we multiply by the conjugate, on the bottom your I terms cancel completely out. That will always happen, that your outer and your inner terms will cancel. And that only happens because we multiply the top and the bottom by that fancy form of 1. So on the bottom now, I have 25, and then this I squared changes to a negative 1. Negative and negative make a positive. So I'm adding 25 and 9 together to get 34. And that's where you stop. Okay. Now, I'm going to cut off this video. If you need to go back and redo anything or relook at anything, I would suggest doing that before class tomorrow so that you feel a little bit more prepared to do the whole group review.